Hi students, welcome back. Coming to our next topic, that is arithmetic logic shift unit. So what is this arithmetic logic shift unit? So far we have discussed arithmetic unit, logic unit and shift micro operation unit. So this arithmetic logic shift unit, instead of having individual registers performing the various micro operations, the computer uses an arithmetic logic unit which combines all the functions. So here it combines the arithmetic logic shift. So all these three functions will be combined in one combinational circuit. So this is the combinational circuit. Here it performing the arithmetic operations, logical operations and the shift operations. So this is an individual which performs all the arithmetic logic unit. So let us see what is this arithmetic logic shift unit will do. So this is a combinational circuit. Here you can see the arithmetic circuit and one is this is a logical circuit. And the inputs for this arithmetic circuit and logical circuits is AI and BI. So AI, BI are given inputs to logical circuit as well as the arithmetic circuit. Okay, and here the output of the arithmetic circuit will be connected to 4x1 multiplexer. This will be the 0. It 0 indicates it performing only the arithmetic operations. Suppose if it is 1, so if the input of the multiplexer is 1, it is doing only the logical operations. And suppose if the input of the multiplexer is 2, it is doing the shift right operation. So if the input of this multiplexer is 3, it is doing the shift left operations. So here it is doing 0 indicates the logical operations. So it is doing it is doing the arithmetic. So it is doing the arithmetic operations. So if it is 1, 1 means 0, 1. 0, 1 indicate it is performing all logical operations. It is connected to the logical circuit. If it is 0, it connected to the arithmetic circuit, and if it is 1 means it indicates that the input is the logical input and we will get the output as logical operations. If the input is 0, 0 means it indicates it. If the 4x1 multiplexer says that it is the arithmetic operations, the output will be all the arithmetic operations output will come like a plus b negate like that. So if it is 1, 0, it's 1, 0 is nothing but 2, means a shift right operation. And 1, 1 means shift left operations, SHL. Okay, so here AI minus 1 is nothing but the shift right, AI plus 1 is a shift left. And here you can see the select S3, S2 indicates the select lines. So the variables that bit operations you are giving. So 0, 0, 0, 1, 1, 0, 1, 1, that is based on selection. And S1 and S0 are the inputs of this circuit. So whether it is, we are selecting the arithmetic circuit and the logical circuit, for both the inputs will be the S1 and S0. Okay, and AI, BI are the inputs and S0, S1 are the selection lines. So Fi is the output. So let us see the functional table of this arithmetic logic unit. So here you can see I is nothing but the carry. Okay, so up to here this S3, S2 is the selection lines, and if it is zeros means if all the S1 and S0, sorry, so if the selection lines all are zeros, if up to here you can see, so here all the selection lines are zeros. 0 is nothing but if the selection line is 0, it indicates it's performing all arithmetic operations. So it is performing arithmetic operations. So that one is clear. So if it selects all zeros, means S3, S2 is all zeros, it's doing only the arithmetic circuit will performing the operation. Okay, and here the inputs for this is S1 is 0, S1, S0. So okay, suppose if both the zeros, if it is F is equal to A, means the transfers the value of A, only transferring the data. If it is 0, 1 means if you get the carry, then you add the carry to that register. Okay, so 1, 0 means if it is S1 is sorry, S0 is 1. It indicates it is performing A plus B. If the carry occurs, it is performing A plus B plus 1. 1 is the carry. Okay. If it is 1, 0, it's nothing but F is equal to A plus B negate. Complement. If carry occurs, just add the carry. Okay. If both S1 and S0 both are 1, it performs A minus 1 operation, and if carry occurs, it just transfers the data. Okay, so these are all the arithmetic operations. Now coming to the, if it is the value is 0, 1, 0, 1 indicates the 1. So up to here. So 0, 1, S3, S2, the selection lines are 0, 1 means 1. So the logical circuit, you have to take the logical circuit. The inputs for the logical circuit you have to take. So here S1 and S0, if both, here the carry will not occur. So in the logical circuit, whatever the least significant bit or the most significant bit that has to be removed, that will be discarded. So in the logical shift operations, you just remove the carries whenever it occurs. Okay. Whereas in arithmetic, you have to be add the carry if it occurs. So based on the condition. So here this 1 will be selected. So the input for this multiplexer is 1. Suppose here the carry will not be there. So it will be don't care conditions. If 0, 0 means if S1 is 0, S0 is 0, A and B operation. 0, 1, A or B operation. 1, 0, A XOR B. 1, 1, F is equal to A complement. This you can see in this logical circuit diagram, whatever I previously explained about whenever I discussed about the logical micro operations. Okay, so these bits performs the logical operations. Now coming to the, suppose if S3 is 1 and S2 is 0, it indicates shift right. So it's nothing but the second bit. So this is second shift right operation. And if it is 1, 1 means it is shift left, nothing but 3. So the multiplexer of the input is 3 and it has to perform the operation shift left. Shift left and the output will be stored. F is equal to shift left A. So these both will perform the shift operations. So shift operations, logical operations, and these functions will do the arithmetic operations. So all these arithmetic, logic, shift operations, everything will be done in one combinational circuit that you call it as arithmetic logic shift unit. Thank you.